All right. Yeah, they're not going to card you at the
Why did they put
YouTube. But anyway, let's close this now and get everybody here. We're doing it live.
Hey, there's someone going.
Yesterday we did substitution where we found that x or y equals a bunch of crap, and then we took that crap and switched it out. Remember that? That was substitution, switching things out. Today we're going to learn something called linear combination, and I'm going to show you what that looks like in just a second. I would encourage you to go get some graph paper so you can follow along. So go get that done now. Yeah, right here.
Drop that. I didn't even touch that. No.
Why does it sound so uninvest?
She give me one.
I don't think point fix are handy. Consensus.
First of all,
It's blurry.
both of these equations are in the same form. What form are they in? Standard, right? Standard. It's the one where the x and y are on the same side. Good guess. They're not in slope-intercept, right? Because slope-intercept gives you the slope and the intercept. These ain't it, right? This isn't point-slope because it's not giving you a point and a slope. It's standard, which is really easy to find x and y intercepts, right? We plug in 0 for one, see what happens to the other, yada, yada, right? But we're not interested in doing that. What we're trying to do is figure out where these intersect, where these two lines intersect. In other words, where they share a solution, right? What's the solution that works for this one and this one? The same x, the same y. Yes, go for it. Okay? So here's how we're going to do it. Before, what we did is we used substitution, right? We picked a variable to get on its own, and then we substituted. So before, what we did was this. We subtracted x, probably, using this equation, and we got this, right? That's probably what you did. You could have gotten x on its own and moved the y over, but most of you guys like getting y on its own. I understand. Now it's actually in slope-intercept form, right?
Yeah.
Okay, cool. Fun fact. What we do then is we take this, because it is y, and we switch it out for y up here. Remember, we don't plug it into itself, right? We know what happens. Danger. Okay?
Can I get an eraser?
Yes. Who?
I'm not going to touch it.
Who?
Why are you throwing stuff at Parker?
I want an eraser, but don't chuck it at me. No.
Keep going. Keep going. Strike.
Need another one?
Dude, how many you got?
Hey.
How many of these?
I'm out.
Oh.
Actually, not just bored.
I see.
Actually, not just bored.
I even a marker.
All right. So then we plug it in here. We distribute the 6, because when we plug it in, we wrap it in parentheses, right?
Yeah.
All right, good. And then we do math. We're not going to do that this time, okay?
Thank God.
Here's another method that works really well when you're in standard form, right? If it was already like this, then plugging it in is not so bad, right?
Yeah.
But when it's in standard form, there's actually a really efficient way to solve this. It's called combination, linear combination, okay? And here's how it works. The numbers in front of variables are called coefficients, right? You totally remember that. 6 is the coefficient of y, negative 24 is the coefficient of x, 1 is the coefficient of this y, 1 is the coefficient of that x. Awesome. So here's what we're going to do. Jace, what are you thinking? Linear combination. Linear because both these equations are lines. Combination because we're going to combine them. Here's how it works. Here's how it works. When it's in standard form, it's super easy to do this. Do you see how my y's are already lined up and my x's are already lined up? That's super convenient. If it wasn't, I could switch them, but they already are. What we're going to do is we're going to make this guy down here look more similar to this guy up here. And here's what I mean by that. We're going to keep the blue equation the exact same thing. Okay? And the bottom equation, I'm going to rewrite. Now, we know the properties of equality. Addition property of equality, which says as long as you add to both sides, it's all good, right? Subtraction property of equality. As long as you subtract the same number from both sides, you're all good. Multiplication property, division property, same dumb crap, right? Here's what we're going to do. We're going to use the multiplication property on this guy here. If I want this y to look like 6y, what would I multiply y by to make it look like that? 6, right? Coefficient of y here is 1. And 1 times 6 gets us this, right? So I'm going to write 6y instead of regular y. Now, in order to do that, I multiplied, right? And I have to multiply everything by 6, right? Not both sides. I mean, technically both sides, but every term, right? So I multiply the y by 6, and that's what I got here, right? So they'd match up. I'm going to multiply the x by 6. So what do I get? 6x. Equal sign. Don't lose your equal signs. It's going to happen to you. Don't be a statistic. Now I'm going to multiply negative 2 by 6. What do I get? Negative 12. And here's where the combination part comes in. I want to make this go away. Because if I'm able to get rid of one of those variables, I have one equation with one kind of variable, right? And then I can solve. So because they're the same, am I going to add or subtract these to make them go away? Subtract them. When you subtract, you're going to be subtracting everything. So you're going to subtract the 6y. You're going to subtract the 6x. And you're going to add the 12. Why am I adding the 12?
Because it's negative.
A negative times a negative is a positive, right? So I'm subtracting a negative. I'm adding, right? What's 6y minus 6y? 0y, otherwise known as nothing. So it's gone.
Seems legit.
Okay.
Negative 24x minus 6x.
That's negative
30x.
Oh, yeah.
Yeah, because we're subtracting. It's all good. You're thinking adding. Again, go back and look at the sign. You're going to forget to go back and look at this thing. You need to. We're subtracting everything. Then we subtract negative 12. So equals, don't lose it. We're adding 12. What's it going to be? What do you have to say?
What?
30.
It'll be 6.
What's 18 plus 12?
What were you going to say? No, what were you going to say?
This is always going to be subtraction?
If they're both the same, you're going to want to. But what if this was a negative 6, right? You'd want to add them. So, 18 plus 12, what's that?
I don't know.
I divide by negative 30, right?
X is 1.
No
Negative
way.
Good catch. X is negative 1. How you like them apples? You might not get it yet, but isn't it feel easier than substitution? It can be. Sometimes it's the right method to use, other times it's not. It's a tool, right? Not everything is a nail. Yeah. So, how did you get to 0? No. So we know x is negative 1. How can I figure out what y is? I hear what you're saying. Here's what we're going to do. We know x is negative 1. That's where they agree. They agree that x is negative 1. So if I plug in negative 1 to either of these equations, I can get y. So I'm going to substitute x is negative 1. I'm going to take that negative 1 and I'm going to plug it in. Would you rather plug it into the top x or the bottom x? Bottom. So when I plug it in there, what do I get? I'm plugging in negative 1 to the bottom equation. Y plus negative 1, whenever I plug it in, I wrap in parentheses, equals negative 2. What's y plus a negative 1? Y minus 1, right?
Yeah.
Solve by adding. Y is 3.
Wait.
Oh, it's negative 2.
Yeah,
My bad.
I was going to say.
That one I didn't mean to mess up. Wasn't just messing with you.
Wait, huh?
I thought you were about to go a fast one on us.
That one was not on purpose. Sometimes that does happen. I plugged in what I found and solved for the other variable. I like that.
It's easier than substitution.
It is. Maybe you disagree. Everyone has their favorite method, and then depending on how the problem is given to you, there might be easier ways to do it, right? So for instance, yes, I can scooch it. Only problem. What form are these in?
Y equals mx plus.
Slope intercept, right? Slope intercept. You could do combination because they're lined up, right? Don't lose your equal sign. Using this method, they're both exactly the same, right? So what if I subtract them from each other? If I subtract them, y minus y is, goes away. Equal sign, don't lose it. -2 minus a -2. So it's -2 plus 2, which is 0x, which is also known as 0. What's 2 minus 2? So I get 0 equals 0. Gentlemen, shut up. What you're saying does not matter. It's also not funny. It's just boring and annoying. And you know it is. So don't make me have to do this. It's annoying everybody else. I don't care. But they do. So, 0 equals 0. True statement or false statement? True statement. 0 always equals 0. Infinitely many solutions. Why? Why are there infinitely many solutions? Explain that to me. What does that mean? Why? Because they pass through every single point. What do you mean? They're both the same line. They're the same equation. So if you were to graph them, wouldn't they be the same line? How often do the same lines intersect? Always, constantly, right? They're the exact same line. They agree everywhere. So infinitely many solutions.
Man, what do you use this?
Well done. Again, think about what it means. They're the same dumb line, infinite solutions. I didn't have to do any of that work. They're the same line. They're going to intersect always, all over the place. This is also what happens when you plug an equation into itself, right? I know, the murder weapon. Let's do substitution. Y equals this, right? So can I take that and plug it in here?
Why do that? You already know it.
Add 2x, 0 x's. Subtract 2, 0. True everywhere. Infinitely many solutions. Smell what I'm stepping in? Now, when you plug something like this into itself, do you see how it's going to be exactly the same thing? That's why when you plug it into itself, you always get infinitely many solutions, because you're plugging it into the same thing. It's assuming that you're talking about the same two lines. That's why you get a true statement like 0 equals 0, or 2 equals 2, or 3 equals 3, or 5 equals 5, or -7 equals -7, okay? What if I got 2 equals 0? Either A, you done goofed, or B, no solution. 2 never equals 0, right? Why would there be no solution? Think about it. Because they never meet, which means the lines must be. Enough! Okay. Too late. It's over. That's it.
Wait, that's it?
You want to spend a whole week on that?
Yep.
Yep, sure.
That's what most classes do.
Yep.
I think you guys are pretty good, actually.
Well, yeah.
Maybe you're not 100%, but you're like,
Well, we're not the
I
pass.
didn't pay attention and I still get it.
okay. Yeah.
It's easy. It's easy.
It's just because Mr. Mac is
All right, so here are a bunch of different problems that I presented to you over a week ago.
Don't make us do it.
Whatever method you want to do, Solve them.
Because,
You just told us that one time.
Here they are. We have three methods. One, graphing. Good God. No, please no, right? Okay? If I asked you, if I said on a quiz, like Friday, and I said graph these two equations and find out where they intersect, could you do that?
Yes.
Right? If it was in slope-intercept form, do the y-intercept and then do the slope, right? That's how you graph that, right? What if it was in standard form? What's the easiest way to graph something in standard form?
Find the.
Find the x and y intercepts, right? Plug in 0 for one, see what happens to the other, right? Graph it, do the same thing to the other, right? I don't know, I haven't made it yet. Could you graph it and see where they intersect? As long as the intersection was nice, right? Otherwise you wouldn't need graphing. If I didn't say graph, you can use any method you want. If I say use substitution, that's the one where you switch stuff out, right? Get a variable on its own, then switch it out. If I said combination, that's what we learned today. Get the coefficients to match. Okay.
Don't make us do it.
yeah, I figured that out. Well, at first I tasted it.
Any method you want, do it.
And I'm like, oh.
Any method you want. Combination, substitution, or you can graph it if you really want to.
Yeah, nothing. I guess I should probably gal.
If you're clever, combination is not that bad.
Just that one.
I found that one.
For now.
So if it's so easy.
That's okay. We're going to get better at that.
Again.
Why
I got it. No.
There's no way you got
Oh.
I got it.
No, you.
Is it? No, I didn't. No, you don't. I didn't do that, but I honestly don't.
Do you know it?
How do you check your answer?
You do it back.
Plug in the coordinate that you think is the answer and see if it comes out true for both, right? If I think 0, 0 works for this, then I plug in 0, 0.
Is it 0?
I get 0 equals 3. Is that going to work? No. So 0, 0 must not be it. But whatever you get, you can plug in and see if it makes sense. Make sure it makes sense for both.
I say it's harder.
Isaiah, you have plenty to do, so do it.
1, 2, or 3, or all 3.
All of them.
All of them.
He's writing more.
Any method you want.
He's doing 4 now.
I'm writing problems down.
Awesome. Don't multitask. In the words of Ron Swanson, why half-ass two things when you can whole-ass one thing?
You're getting them on.
That's why I said
You
it.
guys are gonna look and get the answer.
I know you guys.
Oh, is this hard?
Sure.
This is not a
You shouldn't have asked a question.
Yes, there is. Oh,
Why did you ask that question?
All right. I'm on my way.
Oh, I just did that paper where it comes to the
You want to go
No.
wax them together so you
It's
don't
gonna
all
hold
that
that.
up. Okay? Add it over.
That scared me.
This does not
I
make
feel like you're
sense.
trying to girl like girl.
What's that supposed to be?
She's crazy.
That, not that kind.
That kind of crazy.
I can't disagree with you,
Yeah,
Scott.
she'll call it. Ugly girls? No. Other. I was like, wow. I can't ugly from other. That's what I heard of.
My name is. What did you do here?
It's the opposite. Girls call it 3 divided by 9.
Well, 6 divided by 3 over here is 2.
I don't even want to know if it calls you Dan, because that's just
Shia. Both.
Oh.
Yeah, it would have been easier.
And then
Both two?
Yes.
full Shia. Sage and Do you know Sage?
I did.
Does that surprise you?
I just go.
Put off. That's a
The Sharpie hat. Like while the Sharpie hat is in your mouth, try putting the Sharpie
Probably this small. Let's
inside
see.
of the
What's that?
So you're doing this one. Okay, and you want to know what to do, right? Okay, well there's two things. One, we can take this and plug it in for y up here. Right. Or we can try to make these magnitudes go away. Well, already the y's go away. We're subtracting, right? That's what we just did. So I'm going to subtract. Let's try that. Y minus y is
Try to actually like red over there.
negative 5/3 x minus, always go back to the sign, a third
No, I
x.
know what you're trying to calculate.
What?
Negative
He's
6
like
thirds
that
y.
a few times.
Yeah.
Now we can simplify
Does
this.
anyone like
Just
actually like
three
rate, like,
minus a
the
negative
Sharpie
3.
and just kind of chill there?
Wait for the train to go over you?
Yeah. And just see if they'll like go over you or.
Well, we wouldn't be able to tell the story.
Well, yeah.
Just saying.
Well, it'll, if they survive, you get to see the underside.
That's one way to do it.
Oh, yeah, because if they flip over, you can see.
No,
Well, you're
it's real-
subtracting a negative
okay.
3.
Okay.
So you're adding.
Why are we having this conversation?
So like in the movie, where the person lays down and the train goes straight over them.
Yeah.
You can just see the brown part of the train.
No.
How's it going?
But like, would you actually?
It's not. Isaiah, move here.
Miss Man, can I borrow a pen?
Right here.
Can I borrow a pen?
Isaiah.
Appreciate it.
Hold up, hold up, hold up, hold up, hold up. Huh?
Now.
Oh. English next time.
What's that blue stuff on your face? Yeah. What do you have? You have a little something right there.
I think Mr. Max is like studying pens at people.
Which one? That Parker?
Yeah, but
Wait.
I don't like this.
Okay.
I threw that
No,
person
keep it.
right here, that's why it was on there.
Oh, really? Nice throw.
I did right there.
Can I help anybody
Why
out?
would you throw that at the mic?
Perfect.
Well,
Perfect.
I just
I am
like tossed
confused.
it. Use over there.
All right.
You got friends out the window.
So you did substitution.
No, not talking.
Don't worry about that. You added 3. You got 6. Is what you should have gotten. And then you're gonna add this over, right? So you're gonna get 6/3.
Ow.
6/3 is 2.
You can't see.
All right, so it seems like the most popular way of solving this was by combination, the first one, which is interesting. So what I saw a lot of people doing is subtracting because the y's already are going to go away, right? So when we do that, what we get is y minus y, which is 0. Negative 5/3 minus another third. How many thirds is that? 6 thirds.
Negative 6/3 actually.
3 minus negative 3,
That's a
positive 6. How do we feel so far?
I got it.
If you didn't get it, do you know why you made your mistake and know how to fix it?
Stop it. Oh.
That's one way of doing it. Nevaeh, I didn't see how you did it. I don't know if you you did it the other way. That's cool. Yeah, you like substitution. That was me as a kid as well. All right, so negative 6/3 is the same thing as negative 2. Subtract the 6. Divide by negative 2. X is 3. How do I find y? Plug it in. What's 3 times a third? 3 thirds, which is 1, right? What's 1 minus 3? There's the solution. Nevaeh, did you get this as a solution? Okay, so let's walk through your method. So Nevaeh did substitution. So she said, look, 1.
What?
This one?
What'd you get for the answer?
3 negative 2? Okay. Nevaeh, on this one, did you do substitution?
Yeah.
Okay, so you probably said this is y, so I'm going to plug it in. Is that what you did? Okay. So she said 1/3 x minus 3 equals negative 5/3 x plus 3. So we're going to add 3 to both sides, and we get 6 here. I'm going to add 5/3 to this side, I get 6/3 x. I added 3 and got 6. We good with
I
that?
subtracted 1/3 and put it on the other side.
Okay, so we have 0 left over here, and we subtract the third, and we get this. Yes? Then subtract 6 and move it over. What did you do next? There's 2 things we could do. What did you do next? Did you simplify this?
Wait, that's where I messed up.
Okay, what did you mess up on?
I divided this.
Gotcha, yeah. We want to move the things around to get x on its own. That's cool. All right, so that's not a bad mistake to make. It means you know what you're doing. You just made a dumb arithmetic mistake. Happens. I'd rather you do that than mess up the concept, right? Cool. That's good. So you're getting the new thing. Number 2. How would you solve it? Jace. Makes sense to me, right? We already know y is -1, so why not just plug it in? So, if I plug in -1, I get -1 plus 5 halves x equals 4. Substitution is probably the best method to use here, right? So when I do this, I add 1, and I'm going to multiply by the reciprocal. Times 2 and divide by 5. I'm going to divide by 5, get 1, times 2, get 2. How you feel?
Okay.
I multiply by the flip, the reciprocal. So I multiply by 2, I got 10. Divide by 5, I get 2. I'll write it out. I did this to both sides. The reciprocal, right? This becomes 1 because 10 over 10 is 1. And this becomes 5 divided by 5, 1 times 2 is 2. Better? Okay. So that's 2. And to find out what y is, how do I find out what y is for this one? They already gave it to us. It's -1. Could I plug it in? Sure, you could. You get -1. How do you feel about number 2? All right, that was substitution. A very easy substitution, right? It gave it to you. Number 3, how would you solve it? First of all, what form is this in? Slope intercept. What form is this in?
Standard. No. Point slope.
Point slope, right? Our point is -2, +3. Something like that. Slope of -1. Yeah.
That, please, sir.
Yes, you may. All right. Man came in with half a jug of water, leaving with a third, so makes sense to me. That checks out. How do you solve a problem like Maria?
He just waited to combo.
I need to get gallons more.
Yeah, you can do that. So Parker says, can I plug this in for y? Sure you can. Y is that. That's one way of doing it. Nothing wrong with that.
We just put our parentheses again. That's
Could. Is there a better way? I mean, I'm not saying there is. I'm saying that definitely works. When in doubt, do that, right? We could plug this in. What if you really love combination? What if we did this? How did I get that to look like this? How did I get the bottom equation to look like that? I subtracted the 2. But first I distributed the negative, right? Negative x, +3. What's +3 minus 2? 1. So I just simplified this a little bit, and I got this. And now you can do substitution if you want, which is what you would have done, right? Plug that in here, basically. Or, if you like combination, subtract that whole thing. I do that so I remember to go back to the negative. Y minus y is 0. 1/3 plus 1. 4/3 x. -3 minus 1 minus 4. I'm going to pause for station identification. Negative x, right? Minus a negative x is just plus. So I'm adding 1. How many thirds are in 1? How many thirds are in 1?
2.
How many thirds? 3 thirds. 4 thirds, right? Plus 1 third.
That was really fast.
Are you okay?
Multiply by 3, divide by 4, I get 3. How you feel? For real? Pretty good? Multiple ways to do it. No comprende? Well, it would help if you got rid of your pool game. Why do I say that? Because I'm more than happy to help you, but it's a waste of time when I literally just did the helping, and you're like, nah, I'd rather not. And then right after I do it, you go, I don't get it. Which is good. I'm glad you're saying you don't get it, because you don't.
Like, I kind of get it.
That's great. That's great. Fantastic. Right? That's wonderful. But, like, you would get it more. Maybe not all the way, but you would get it more. Wouldn't get it less
Yeah.
if you watched it the first time. So, I don't know. Maybe watch it the first time, right?
I was paying attention yesterday, and
I know. But I think you'd do better. How much better we can debate. But you would do better if you weren't looking at that. So, like, why not do that?
He ain't very smart.
I don't know.
Because I like playing pool.
Yeah, I know, but like, why? Like, when I was a musician, and I still am, I suppose, I realized that I was so good at Guitar Hero, I was better at that than I was at actual guitar, like my actual real thing. And I was like, shit, man, like, I'm wasting my life doing this. Like, I should just be playing regular guitar, right? Are you going to be, like, a master virtual pool player? Is that your goal?
Pool shark. Yeah.
Okay, then I guess you should spend more time doing that than doing
He's got
this.
to end here in the park reading.
Got him. All right, so number 4. You do you, right? So number 4, how do you want to solve it? Substitution, elimination. We'd have to do some work, right? The combination that I told you about, right? We'd have to distribute the quarter. We'd have to line up our y's and our x's, right? Probably don't want to do elimination here. We probably want to use your method, right? Substitution. So let's take this. Are you going to be okay? We're going to plug that in here for y. It's going to look weird, but it's going to be fine. A quarter. When we plug in for y, I'm going to use a different bracket just so I can tell them apart. It is, but it's not that bad. Get used to lots of brackets. You're going to have more and more. You're going to have lots of things plugging in and lots of different equations and things as you get older. It's going to be okay. Now, we have 5x minus 4 minus 5x. That's all subtraction, right? So do I need any of those parentheses? No, I just need this one. It's all the same thing, right? What's 5x minus 5x?
That's 0.
So they go away.
Negative 4. Oh, that'd be negative 1.
What does it mean?
Forgot the negative.
What does it mean?
Same line.
They're the same line. They're both the same line, so they are constantly intersecting infinite solutions.
Yeah.
Doesn't look like the same line, but they are. Turns out, we just proved it. More you know. More you know. What if that was not a minus 1, it was a plus 1? No solution!
Okay. I do. Oh, wait, do we do something?
Yep, always.
Do you know who Owen Musman is?
Nope.
Okay, well, he's not like special ed, he's like little special.
All right, I'm going to stop you right
No, I
there.
said it in a nice way.
I'm going to stop you right there. Moving on. So, that's my nice way of stopping you. So, that's as bad as it can get. I might say you have to graph it. I might say you have to do substitution. I might say you have to do combination. Will you be okay with that? Will you be okay when you get something like 2 equals 2? Will you know what to do with that?
Yeah, infinite.
Infinite solutions. What if you get 2 equals 5?
No.
That's it. I feel like we could spend a week on this because that's what it's like supposed to be, but like why? Let's take a quiz on Friday. We'll review tomorrow. Friday is midterm for quarter 2, which means report cards will go out to parents. This will be your second quiz on on quarter 2, so make sure you knock it out of the park. Yeah. You can come on in. What's up? I'll get mad. Yeah. I'm such an angry person. Yes. Oh man. No, it's okay. It's my bad. It's okay. Oh man.
But then it just says that.
Hey, I got an eraser.
It is tough.
Oh, I was looking for
If I feel enough, it will just go
Yeah, it was my fourth one. Appreciate it.
Hey, can I leave?
No.
Hey, can I go?
I would let you all leave if you wanted to, but like you guys are too dumb and you'll get caught, and then I'll get in trouble. Let's be honest.
Actually, I would get caught.
That's not true.
I would go out the window.
You would.
I'm a nice person.
I know. You would get caught. All right. Nice. All right. That's that on that.
We'd be the ants walking in the teacher's class and be like, yeah, my MCC
No, I was at I feel like I was at
Get this all filled out, and then after you retake it, we'll staple that to it. Okay? And I'll fill out my stuff. Okay? Again, that's the last step. Just make sure you have it ready to go.
Wait, so do I need to get this one?
Yeah, you got to prove it. You're good.